Hello, this is Jeffrey Fox, Big Data Applications Analytics course, motivation, overall view for the course. This is lesson 15, and it's sort of as an aside. It's about data science education itself, and it's slightly relevant as this course is, is actually probably mainly taken by data science students. And this discusses effectively data science in universities, although the field in many ways was generated by industry. Certainly, the one we set up at Indiana University was somewhat motivated by me working with industry through the National Institute of Standards and Technology. And I was amazed by how many people said they were data scientists. That's not something I'd heard back at the university at the time. That was 2013. Anyway, there are some many articles on this. Here's probably a rather old one from New York Times, 2013. But McKinsey has just come out with a pretty interesting one here, end of 2016, with a particular focus on data analytics and why you need to know deep learning, clustering, dimension reduction, and all your various classification and prediction algorithms. And this followed an earlier one in 2011, which actually was pretty important to Indiana in planning its initiative, because it's the article which really identifies the opportunities of jobs in this area, finding 1.5 million management type jobs, which corresponds to our decision maker track, and 190,000 technical jobs corresponding to our technical track, and these were jobs in the US in 2018. So let's get going with a few remarks on data science education and also distance education, MOOCs and things like that, which is an area that's always been of interest to me, although I've never put enough time in it to be super successful. All right, here's a beautiful picture from the NIST. Here's the link down here, and they had a so-called Big Data Public Working Group, and as part of that working group, they defined the various terms in the field, of which data science and data scientists were good terms. And here's data science as the extraction of actionable knowledge. Remember I did DIKW, data, information, knowledge, wisdom. So data scientists are the people who are processing that pipeline. And data scientist implements that pipeline, and he has to have some knowledge of these various overlapping domains. The longer discussion, which you'll find in these links down here, points out that it's not so obvious when you need doing data science whether you need individuals having knowledge of all these domains, but rather they could have knowledge of, say, those could be super programming and have some knowledge of statistics and data mining and analytics and algorithms, or they could have an algorithmic influence and then they'd work in a team where the programming is done somewhere else. So due to the fact that the projects are done in teams, data scientists are meant to have a broad knowledge of the field, but they can specialize in one of these areas. There's a field which is somewhat older, but is not really advanced so much, computational science, which is really the same as data science, but studying simulations, not data analysis. And there you would, instead of having statistics and data mining, have applied math and modeling in this circle here. All right, data science is great and very important. Here is some comments on education. Obviously, when it started in industry, the people saying they were data scientists in industry didn't graduate with data science degrees, at least the ones I met in 2013 didn't. They actually came with other educational backgrounds and became data scientists due to the nature of their work. There is little doubt that having an education program was initially controversial, but now it seems to be reasonably well established. Just look at all these universities: Stanford, CMU, Columbia, Johns Hopkins, New York University, Michigan, Ohio State, Berkeley, Chicago, Yale, Washington, Seattle, Edinburgh, UIUC, Urbana-Champaign, Illinois, MIT, Harvard, UPenn, University of Texas, Austin, and Brown. These all have data science initiatives. So that's really well established in the many leading universities. And the reason it's well established is the number of jobs, which is what was in that McKinsey report, that there are many jobs in data science. And there is lots of differences about the way they're implemented. Should it be put in computer science? Should it be put in statistics or math? And what should it be? A minor, a track, a degree, a certificate? And is it a department or an interdisciplinary program? Indiana is evaluating these options now. Currently, it's effectively a program. There is a curricula, but it is not a department. That is actually a pretty reasonable thing to do. That should be done more often in academia. You don't have to be a department to thrive. You can be a cross-department initiative. That's where you get more interdisciplinary work. Here is just a little plot showing the growth that I and a few others started it here. I've sort of dropped out now. I'm in engineering, but you can see it's thriving. 585 is the estimate for this fall. I'm giving these lectures in fall of 2017. It is joint between the 4 units in the School of Informatics, Computing and Engineering, Computer Science, Informatics, Information and Library Science and Engineering, and it also involves the Statistics Department in the College of Arts and Sciences. There's an online certificate, an online and residential master's, and originally we actually thought probably that the online would totally dominate, but actually the residential is very strong, and the online is actually bigger than the residential, but not drastically bigger. So, of course, that's why these classes are online, is so that we can use it in the online masters. So, and the reason, of course, why this type of field is good to offer online is particularly attractive when there are not many residential programs competing with it, because then a broad range of people can actually take advantage of it, which they would not be able to do otherwise. They wouldn't be able to pop down to their local university and take it there. Rather, they would just sign on online. So the online has a lot of professionals, people with jobs doing these things on the side, whereas the residential, of course, are full-time people. Here is another interesting graph. It is about, it compares the number of job postings, and it looks at data scientist. And notice that 2 versions of it, one in quotes and one without quotes. Of course, all that means is when you put the quotes, the word scientist has to follow data. When you put it without quotes, scientist and data can be anywhere in the job ad. It's worth noticing the computer engineer is 0.28%. If you remove the quotes, computer engineer will be 4%. But anyway, all these numbers are pretty impressive. Note machine learning, it's almost 1%. Artificial intelligence down here is not so large, but even though there are more or less operationally equivalent AI and machine learning at the moment. Big data is 0.84%. And the other. Actually, machine learning is the other big one. But here there's only data scientists, this one here, and computer engineering here are quite solid. Now it's worth contrasting this. This is the job postings coming from the job ads. Here is the job seeker interests. And what's remarkable is that data science in either form is the most is the largest category by far. And there aren't so many people looking for, say, here's computer engineering, not so many people specifying their interest as computer engineering or big data or machine learning, but a huge number specifying them as data scientists. I'm not quite certain what the significance is. Notice a mismatch. These numbers here are down almost a factor of 5 to 10 over this number here. This one here is um, uh, these are about 0.25%, 0.25%, and these numbers here are 0.01 to 0.02, a factor of 10 lower. So that's maybe important. Maybe that also illustrates a mismatch between the job skills of those seeking jobs and the job skills of those posting jobs. All right, let's get on with some further general remarks on this field. This is sort of the up-to-date summary of the status. Thank you very much. Geoffrey Fox talking here. Here is a nice plot from my favorite Mika KPCB internet discussion, which looks at online enrollment and gradually increasing as a percentage. It's now up to nearly 30%. And here the green are the taking at least one course, and the orange is the percentage of total enrollment. So here we have some other statistics. iTunes Open University in the UK, and this is how it's downloaded by the different regions. It's actually, I didn't realize the Open University has quite a lot of broad country coverage, with the UK being high because that's its host, but also China and the US being major users of the Open University. We have here a Coursera, which is of course the most famous of the startups in this area. Udacity and Khan Academy are other examples, perfectly, maybe equally, comparably successful. And here you have the course enrollment. Coursera is up to over 8 million here, and the number of students down here is 4 million, because obviously a given student can enroll in more than one course. And here you again have regions with North America, Asia, Europe, and other. And of course, you don't have the United Kingdom because Coursera is a US activity and is not special to the United Kingdom. All right, so if we look at MOOCs, they're massive open online courses. Now, my course is hardly massive in terms of number of students, but it uses the same technology as MOOC, so I say that it is a MOOC. And they have hundreds of thousands of participants in a Coursera or Udacity popular MOOC. And as I told you, why it's relevant for data science, because it's a new field with not many universities offering it. So it's particularly attractive to have a source for online MOOCs. And let's say the typical model is what you're seeing here. Pre-recorded segments in the 3 to 15-minute range. This is something to do with you getting bored. The claim is that if I talk for an hour, it wouldn't make any difference as me talking to 15 minutes. You will be asleep. This way, you can listen to me for 15 minutes, jump up, run around the building, scream, have a cup of coffee, do whatever, do your email, or do whatever you want, and then you'll come back to the next lecture. Sorry, next lesson, I should say. Lectures, which are called units in this thing, are divided into lessons, and those lessons effectively are thought of as like songs in the classic iTunes sense, or given music manager, because you form playlists, which are a collection of songs, and that's effectively what this Google Course Builder technology does. I'm at the moment recording a song corresponding to lesson 15. This particular disc has 16 lessons on it, 16 songs, and together those 16 songs taken in a row produce the overall experience. But the songs are actually relatively independent. They've been carefully designed to be roughly takeable on their own. And So this approach says you bring everything in terms of lesson objects. Those lesson objects are composed, and you should have a repository of them, and lots of songs, and then you can reuse the songs in different ways. You can run tutorials, classes, and what have you. Here's one of the earliest things I ever did, which was the first version of this particular class, and this has now been replaced by a newer version, but you can see the elusive Mr. Higgs. That was the physics unit, the data deluge, and so on. And these things are units. Units have become lessons. And this was how Google Course Builder used to produce runs. And now this has been replaced by what you see here. This was the first time we did it. And if you look inside that, if you go to Unit 2, the scientific method, it would have 7 songs in it or 7 lessons. And Google Course Builder will list the lessons with their titles. If you click on the lessons or do a mouse over, it will tell you an abstract of that particular lesson. Here is the abstract of the unit. So the feature of Google Course Builder is that every item in the hierarchy, which in our case is actually now course, section, unit, lesson, because we decided to join the units together to make a coherent collection. Each of those level of the hierarchy has an abstract. So this is coming back to some more general discussion of MOOCs. You can do one class to 100,000 students. Are using this customizability in terms of songs, lots of classes, each of which is a smaller size. I take 50 as a typical size of a conventional class. And if we go to the second way of doing it, then you can use conventional technology. And what you're doing is you're probably having different professors in each of these classes. They're all mixing and matching and producing customized classes which are particularly appropriate to the student body they're responsible for. And depending on their preparation, they might need a different selection of songs. You can also do it, and this is what Judy Chu did in her cloud course, allow students to customize their own experience. This, of course, is what iTunes allows you to do. In every case, this repository of lesson objects, 10 to 15 minute video, PowerPoint plus Talking Head is supported. This repository of lessons supports this model. And both teachers and students can actually choose from this repository. And then we produce customized courses optimized for each target audience. Here's an example of the very first repository we built of Science Cloud presentations. So we have there's 20 units, and each of them is around 6 lessons, and we got a total of 150 lesson objects in this collection here. So this is available. This is still available. It's now a little out of date because this field changes so rapidly. So another example of this customizability is you can enable you to do outreach in an interesting fashion. So Judy and Linda Hayden from Elizabeth City State are aiming to customize modules, which takes cloud computing lessons, songs, if you like, from the cloud computing MOOC at IU, add material on the particular area that's covered by the ECSU course, which is actually remote sensing, and that allows you to get allow Judy's material to be used at Elizabeth City State, and Elizabeth City State students to have cloud computing, which without their faculty directly having to worry about learning the latest details of clouds. So this is an example of this customizability, and it seems to me quite promising. And I effectively did that myself using older technology about 17 years ago, around 1997, with various small colleges. Jackson State isn't so small, but it's a historically black college where the faculty were not at that time familiar with Java. I taught the first Java classes by reusing the Java courses I had from Syracuse University and retargeted them to Jackson. And I offered that online with much earlier, less powerful technology. But this basic model is a proven model. And we're still working on how best to do computing labs with appliances which download to clients. This DevOps and containers and things is obviously a critical idea here in going forward. Here is Judy's cloud course, which I mentioned on the previous slide. Always the songs in Google Course Builder are stored on YouTube. They're either prepared, this one is prepared with Microsoft Mix, but you can also prepare them. The older ones were prepared with Adobe Presenter, and Camtasia is the editing software. And you can do lots of different interfaces to these songs, which is again true of music sites. You can take the same music tracks and you have lots of different websites you can use to access them. So I mentioned here the two limits where MOOCs are particularly attractive: high volume courses, CS, initial CS, physics, chemistry, biology classes, where the scalability makes them attractive to reach a lot of students. And then these niche areas, which is sort of where I work, where there's student interest, but either not enough faculty expertise or not enough students to justify a course at the individual university. So you need to offer them many in the institutions simultaneously just to get enough, because no one institution can actually afford to offer it because there's just not enough students or not enough faculty interest to implement. So here I discuss a concept I once had called the Hermit's Cave Virtual University. And it was I was at Syracuse at the time, which is associated with near the Adirondacks, where you might have expected to have hermits having remote caves where they think great thoughts. And in 1999, which again, I made a mistake and misjudged the pace of online education. I assumed online education would have huge importance and change the way everything was getting done. And I assumed the model was going to be the virtual university where faculty were spread around the world in their favorite location, which I enigmatically called the Hermit's Cave, with me in the cave. And what were universities? They were just virtual organizations that provided the necessary courses and structure to give credentials, degrees, and stuff like that. And faculties would teach in this virtual university, and maybe universities would have repositories and so on. And I proposed this virtual model for education. It was a total failure. Nothing happened. But now we're sort of starting to see this. Note one interesting feature about Microsoft Mix or Google Course Builder. You have no need for local resources except for the faculty laptop, and the entire course can be stored on the cloud, and this cloud is actually a public cloud, Google or Microsoft, not actually the university. So we can actually at least do some important changes here: cross-institution virtual education, and we do cross-institution research. And this is all enabled by the cloud and high-performance reliable networking, something that did not exist in 1999. So it would be good to set up a community to define this virtual universities and what we need to support them. Then we can close all our universities. Or maybe we need to keep them so we have basketball teams and football teams and so on. But and also parties and other important things that universities do well, and the real reason why students go to them, maybe. A few comments on mentoring and grading. I think this is not a terribly well understood area. This course has rather successfully used forums. We have used Google Community Groups for our forums, but Coursera, for example, has its own forums. We have also used Hangouts and equivalent for various discussions. They're okay. They're not quite as important, I think, as forums. Um, and Hangouts have some limitation in terms of number of people. But if you get to much more than around 10 people, then you'd find it's pretty difficult to have interactive sessions. There are too many people involved. So this whole area of mentoring and grading is not clear. We do all the grading in entirely dull, conventional fashion and do not expose any novel ideas here. Here we have come back to the famous Meeker analysis. So this was about learning tools in 2013. Well, actually, it's 2012. Reported in 2013, and it's sort of interesting how they rank. This is 2012. Twitter is very highly ranked. I must admit, in my experience, I've not seen Twitter used for YouTube, Google Docs, Dropbox, Skype is PowerPoint. I would have been a bit surprised PowerPoint's not higher ranked. Facebook is also, I'm surprised, it's not higher ranked, although it's certainly doing a lot better as we go from 2009 to 2012. Moodle, a classic learning management system. Evernote's a well-known technology, sort of related to Google Docs and types of things it does. SlideShare has got less popular, interestingly enough. It's sort of the trouble about SlideShare is it doesn't have the videos attached to it. And I'm not a great expert on these other ones. Prezi, WordPress is essentially a website technology. And we know how Dropbox is important for sharing resources for students. So this is not only delivery, but also preparing the material. So it's much broader than say, Course Builder. Here we have the final slide of this lesson, Song 16, which just comments on the synergies between clouds and universities. And so we use the clouds to support research. The clouds are used for doing data analysis, and they use core cloud technologies, which you either use or you develop. We can also, of course, teach cloud. So there's a cloud computing MOOC. I showed you Judy Chu's cloud computing MOOC. We can also use clouds in the sense that this course is using clouds to support distributed learning and, of course, distributed research. When I use Google Docs in my research work, I'm using a cloud to support distributed research. So here we have a cloud backend for course materials and collaboration. And of course, all of this is potentially a green, environmentally friendly computing infrastructure, and it should be considered as the future of university academic support. So that's the end of these comments here on data science education. Remember, it's just there as a sort of, it's a backdrop to what we're doing. It's not a central part of this course. Thank you very much.